welcome back. This video will be about Birkeland Eyde. Basically, it's the old-fashioned method of making nitric acid from air, to be more precise, from nitrogen, which gets oxidized in a flame, electric flame. And building it was quite a challenge because of the temperatures, the high voltage, and well, my engineering skills are not that good. After a whole lot of prototypes, I came up with this. It's a glass cylinder which is bolted onto a tile. So the outer bolts are for holding the cooler. The inner bolts are for clamping down the glass cylinder. So this is standard issue PC cooler. The cylinder was getting ridiculously hot, and I was scared of damaging the glass or breaking it. It seems to be stable for now. So there's the neon transformer. It's 4.5 kilovolts, rated 0.45 amps. It's an air pump. It's one of the strongest aquarium pumps I could find. I built a regulator for the airflow. The tap allows me to adjust how much air flows into the flames. This tube. I will draw a schematic because it's all kind of messy with all the tubes. So it goes. It's the right one to the right. Goes into a glass tube, which ends up inside the reactor, and it blows through the electric flame. So there's an exhaust tube, which is with the green clamp, which goes into this large glass cylinder, which I bought for a couple bucks somewhere. Quite often I see designs that lack this feature. I've been reading a lot about Birkeland Eyde, and the original design, they had large towers where it was allowed to oxidize, because it takes about a minute or so for the nitric monoxide to oxidize to nitric dioxide, and this fat allows me to do that. The outlet is in it. It's a bit hard to see. The outlet is a very small tube with a small opening, which makes sure that the nitric oxide is in there for some period of time. There's no real way of telling. I tested it with smoke, and the smoke particles stay there for at least a couple minutes before being flushed out. Then we follow this tube, and it goes into the first scrubber. This is not very optimal, and I'm still working on a better way of doing this. This is quite hard to see on camera, but it has a couple holes on in the side, which allows for small bubbles. But as I mentioned, it's hardly optimal. And it goes to the second oxidizer, because after it reacts with water, it will also release nitric monoxide again, which can be reoxidized to allow for a second scrubber, which is this one on the back. Alright, so the airflow is turned on. As you can see, the flame is getting disrupted. Try to focus the camera. It's better. Controlling the airflow is important. Too much air, and it will cause the arc to be not to be able to form. So it might be a bit hard to see on camera, but the cylinder is slightly yellow because of the nitrogen monoxide and dioxide. Okay, so we follow the tube to the oxidizer. And again, it's too bad that this is hard to see on camera, but it's already getting yellow. And I had to run it for about a minute now, so it seems to be producing a lot of gas. So one of the things that I'll have to improve is the scrubbing train, because this isn't very efficient. Originally they used absorption towers of 40 meters high, and they would spray water on top of it. But so far the pumps I've looked at are not capable of resisting the acid. Many of the designs I've seen so far lack the proper oxidation time, which might explain their inefficiency. As for the scrubbing as well, they use regular scrubbers, which is not enough. It's inefficient as it is, and it's important to optimize those things. So, and just to show you, I'll turn off the airflow just to let you see what happens to the arc. Currently it's a backflow. This is what it looks like when there's no air blowing through it. I'll get back to you with proper scrubbing, and I will still have to adjust some things in my reactor itself. So after to turn it off, I'll have to cut the power supply and let the oxidation chamber run empty. I still have to run it for multiple hours at a time. My lab is not next to my house, so this is not something you want to let run unattended, especially highly experimental setup like this. But we'll get there. So thanks for watching, and I'll be back with you with more updates.